All right, today we're going to do something a little different. We're going on a journey, peeling back the layers on an action you do all the time without even thinking about it.
I mean, how simple can it get? You hit a key, stuff happens. But what if I told you that one little press kicks off this insane, super fast chain reaction? It's a journey from your fingertip down through the guts of your machine, all before you see a single thing change on screen.
Okay, so let's start with what we all know. You're in Microsoft Word, you hit enter, and boom, you get a new line or a new bullet point. Simple, predictable, but that's just the end of the story. The real magic is how we even get there.
So, let's start right at the beginning, the physical key. When you press that Enter key, you're not actually sending the letters ENTER into the computer. Nope, you're sending something way more basic.
And that something is called a scan code. Basically, your key press gets translated into this unique number. Think of it like a secret ID for every single key. The computer doesn't think in letters or words at this level. It just sees these codes.
And get this, it's incredibly specific. Just look at this table. When you press the A key, it sends the code 1E. But when you let go, it sends a totally different code, 90. That's how your computer knows you're holding a key down. And it gets even crazier. Keys like the Enter on your number pad or the Windows key, they send out a whole sequence of codes just to make sure the computer knows exactly which one you meant.
All right, so the keyboard's done its job, it's got a scan code. Now what? It has to somehow get the attention of the main processor, the CPU. And you gotta remember, that CPU is already juggling a million other things. It can't just be sitting around waiting for you to type.
This is basically the map of how it all connects. The keyboard isn't just floating out there, it's physically wired into the computer's main communication highway, the I/O bus. That's the road that all information travels on, between the computer's brain and, well, everything else.
So how does it get the CPU's attention? It uses something called a hardware interrupt. And honestly, the best way to think about this is like a doorbell. The CPU is busy doing its thing, running programs, calculating stuff, and the keyboard just rings the doorbell. The CPU has to stop everything it's doing, go answer the door, and see what the keyboard wants.
Let's break that down step by step. So first, the scan code goes to a little controller right on the keyboard itself. That controller then sends out the interrupt signal, the doorbell ring, on a specific wire. The processor hears it, stops, and looks up in its instruction book, okay, a keyboard interrupt. What do? It runs a special little program called an interrupt service routine. That routine's only job is to go grab the scan code from the keyboard. And just like that, the operating system finally knows you pressed a key.
And here's the thing, your keyboard isn't the only one ringing that doorbell, not by a long shot. Your mouse is ringing it, your Wi-Fi card is ringing it, your hard drive is ringing it. They're all screaming for the CPU's attention. The system has this clever priority list, a daisy chain, to handle all these requests without completely freaking out.
Okay, so the OS knows a key was pressed, the Enter key specifically. But what does Enter even mean? This is where it gets surprisingly messy. Welcome, my friends, to the line break wars.
So to us, Enter means new line. Easy. But behind the scenes, in the code, there are actually two different ways to say new line. On systems like Linux or Mac OS, it's just one invisible character, a line feed, represented as /n. It just says move down. But on Windows, oh no. It uses two characters. First, a carriage return, /r, to move the cursor all the way to the left, and then a line feed, /n, to move it down.
So why on earth is it different? Well, believe it or not, it's because of old-school mechanical typewriters. You had to do two things, right? You had to physically slide the carriage back to the start, and then you cranked a lever to feed the paper up. Two actions. Unix came along and said, that's silly for a computer, let's just make it one thing. But MS-DOS and Windows decided to stick with the old two-step way, and because they became so dominant, that split is still with us today.
And look, this isn't just some nerdy trivia. This has real-world consequences. As this quote points out, if you've ever opened a text file from a Mac or Linux user on your Windows PC and it was all just one giant jumbled line of text, congratulations, you've just become a casualty of the line break wars. Your computer literally didn't understand how to make a new line.
So, okay, the OS has the character or characters for a new line. It then hands that information off to whatever program you're actually using, and now it's up to that program to figure out what to do with it.
And depending on the program, Enter can mean very different things. Think about a command line or a terminal. When you type ls and hit Enter, you're not just making a new line. You're giving a direct order.
You're telling the operating system, hey, go run this program for me, right now. It's an execute button.
But what about on a website? How does Google know you've finished typing your search and hit enter? For a long time, programmers used an event called keypress. But just look at this. On the left, you've got a developer on Stack Overflow basically yelling at people, do not use keypress. And on the right, that's the official word from Mozilla, the makers of Firefox, saying, yeah, that feature is deprecated. It's old news. Don't use it. It might break at any moment.
This is wild, right? It shows that even for the most fundamental action, detecting a key press, the rules are always changing. Today, web developers use more reliable methods like key down and key up, which, if you think about it, goes all the way back to what we first talked about, those scan codes for pressing a key down and then letting it go. It's a much more direct way of listening to the hardware.
Okay, let's take a breath. Scan codes, interrupts, line break wars, deprecated code, why? Why is all this insane complexity hidden behind one of the simplest things you can do on a computer? Well, the answer actually teaches us some of the biggest ideas in computer science.
It all boils down to a few core principles. First, you've got abstraction. All that crazy hardware stuff is hidden from you so you can just type. It's brilliant. Then there's standardization. Things like scan codes mean you can plug pretty much any keyboard into any computer and it just works. And finally, and maybe most importantly, there's legacy. The ghosts of the past are still in the machine. Decisions made for 19th century typewriters are literally still causing bugs in 21st century software. The journey of this one key is basically the story of computing in a nutshell.
So, that little enter key, it's hiding an entire world of incredible, elegant complexity. It's built on decades of history, clever engineering, and some truly brilliant design. And it kind of makes you wonder, doesn't it? What other simple things that we do every day are powered by this invisible symphony of code? What happens when you just move your mouse?